Good afternoon, everyone. I am Baban, and today I'll present some questions on clustering, and then we'll discuss about some coding problems also that can help you to solve the assignments. I'll just wait for another 1 or 2 minutes before starting. Okay, so let me start. At first, I'll go through the MCQ and questions, MSQs, and then after that, we'll go to the coding. So this is the first question. So we have what are the assumptions that we make when we perform K-means algorithm, K-means clustering, and we are assuming that we are using Euclidean distance. So we have 4 options, and we have to select which among the 4 options are the actual assumptions that we make uh, during like K-means clustering. So we'll go one by one. So first option, clusters are spherical in shape. So is it an assumption in K-means? Yes or no? You can write the answers in the chat box. The first option, is it correct or not? So this is a MSQ question. Okay. Okay. Yes,
Can you show the question?
yeah. So first option is correct. So we'll go one by one for all of the options. So first option is actually correct because in K-means algorithm, we assume that clusters are roughly circular or spherical, and this is like the basic assumption in K-means actually. So whenever we are using K-means algorithm, we are assuming that the clusters are actually circular in nature. Okay. Then second assumption is that cluster are of similar sizes. So is it correct? Yes, this is also correct. So in K-means clustering, we are assuming that when you are clustering the data points, we are assuming that they are like having similar variance, and dispersion is also similar, variance is similar. So in K-means, what happens is that we treat each cluster uh, equally, right? So it doesn't matter if any one cluster is having 100 points or one cluster having only 5 points, we are treating them equally. Okay. So the basic assumption is that we are assuming that they are equally important. Okay. So this is the another assumption that roughly all the cluster are of kind of similar sizes. Okay. Then data points in one cluster are well separated from other cluster. So is it true? So do we need to assume that? So if we are having some cluster here and another cluster here, and we are assuming that all the data points are well separated, like there should not be kind of intersection, that kind of thing. So is it true? Is it an assumption in K-means? So that is not really the case. So whenever like in K-means, like you can see that they are a kind of like we do not really make this kind of assumption when like they are not also like they are totally separate. Yes, when we cluster them, they can come differently, but this is not the basic assumption that if there are any overlap, that then this algorithm will not work. That kind of assumption we are not making. Okay. Then last option is also incorrect. So there are no wide variation in density among the data points. So basically what we are saying that suppose in one cluster in this there are like 10 points, and in another in similar size there are like 100 points, so density is much higher. So we are saying that this kind of thing we cannot handle with K-means. So that is not really the case. There is no assumption during K-means algorithm that if the density is higher than another one, then the algorithm will not work, or that is the like ideal situation that it should be density should be similar. So this kind of assumptions are not there. So this is also not correct. Okay. So let's go to the next question. So which of the following can act as possible termination condition for K-means algorithm? So whenever you are running a K-means clustering algorithm, and how can we stop the like we can run it for multiple iterations. Okay. So when we can decide to stop it for a fixed number of iterations, is it a valid method that maybe just run for 10 iteration and then stop? Is it okay? Is it doable in K-means? First option. Yes, actually, so we can do this. We can obviously run a K-means algorithm and say maybe just run it for 10 iterations, and then whatever we are getting, that is fine. So this is correct. Then we can do another thing. Second option is that assignment of observation to cluster does not change between iterations. So suppose we are running fifth iteration, sixth iteration, and seventh iteration, and we are observing that clusters are not changing at all. So we can say that even if we run more times, it won't affect much or affect at all. So we can also use this as a criteria for for termination condition. Then another one is that centroids are not changing between successive iteration, maybe fifth and sixth iteration. We are seeing that all the centroids are remaining the same. So that we can also use. And also another one is that when RSS falls below a threshold, so maybe let's say we consider that 50 is a good enough. So if it is falling below that, then we say that yeah, it is fine, no need to run it again. Okay, no need to iterate it again. So all four are correct options here. Okay, so I'll go to the next question. So we have a agglomerative clustering here. Okay, and here y equal to 2, we have a line here. Okay, at this point. So if we consider y equal to 2 here, what is the number of clusters here? Right. So here the number of cluster is 2 because if you look through this line, there are two intersections here. Okay, that is like from that you can easily identify that there are two clusters here at this point. Okay, so we have these 3 points.
So how it is? How is this two inches?
Yeah, so if you look at this line, okay, this line, if you go, there are one intersection here and another intersection here. So there are, you can say, two clusters here. Okay. So basically, below this point, there are two clusters coming from here, and then after this line, we are merging them at some point. But right now, at this point, we have two clusters. You can find this out by seeing how many intersections are there. One and two intersections. All right. So like you look through the line here, y equal to 2 and two intersections.
So what will be the for that? Suppose for y other values of y. Suppose y equal to 1.2.
1.2, so it will be like around here, right? So
Yes.
1, 2, 3.
3.
Yeah.
Oh, oh.
Okay. So suppose you are having 3 points in a cluster, 1, 1, 2, 5, and 6, 8, and you have to compute the cluster feature. So I think it is. I have seen it has been covered in the lecture to how to calculate the cluster feature. So can you do this? So cluster feature is kind of like there are three values.
Sir, here we have to give the values or
Yeah, you have to give the values. Cluster feature is like three values, right?
it's like 1, 2, root 2, like that will come.
Okay, it should not. Can you write that in the chat box?
Okay, okay,
Root
sir.
should not come, I guess. Yeah, root should not come. Yeah. N sum squared sum. So what will be the value if you take n sum squared sum? 3 1400. So 14. Okay. So 2, 2 plus 7. Uh, 1 to 4. So I'm not getting what is in here. in sum squared sum is right, but what are the values? These are not the correct values. 3, 14, and 100. This is not a correct value. Okay, let me go to the solution here. So what we have to do is that we have to calculate the n, then sum, and then squared sum. Okay, so n, how many number of points are there? 3, 1, 2, 3. So we write 3 here. Then we have to calculate the sum. Okay, sum of the first coordinate, sum of the second coordinate. So sum of the first coordinate is that 1 plus 2 plus 6. Okay, 1 plus 2 plus 6. Okay, then sum of the second coordinate is that 1 plus 5 plus 8. So 1 plus 5 plus 8 is 14, and 1 plus 2 plus 6 is 9. Then you have to take squared sum. So squared sum is 1 square plus 2 square plus 6 square. Okay, plus 1 square plus 5 square plus 8 square. So 1 square is 1, 2 square is 4, 6 square is 36, 1 square is again 1, 5 square is 25, and 8 square is 64. So if you take the summation, it is 135. So 3, 9, 14, 135. So this is the correct answer.
Sir, this this last option, no? So squared sum.
Yeah.
We have added or everything like x and y.
Mhm.
It's not like sum, no? 9 and 14. So here it should be
Yeah, you can also
individual.
do it via this. So 1 plus 4 plus 36, comma like 26 plus 64. You can also have it. Look like do it like this.
Both are correct.
Yeah. Okay. So the next question. So this is about like hierarchical clustering. So one thing to note here is that from this given matrix, we have to find this the tree by single linked approach. And one thing to note here is that here we are given similarity, not distance. Okay, so this is a similarity matrix, not distance matrix. Let me repeat that. So with distance, what happens is that similarity means it is opposite of distance, right? So when you are using single link, what do? We find for one with the least distance, right? So with single link, we try to find the clusters with the lowest distance. But here, as we are given similarity matrix, we have to find one with highest similarity. So highest similarity means lowest distance, right? So by that method, which option is correct? I'll give you some time because it will little bit lengthy. So like please note here, we have mentioned it is similarity matrix, not distance matrix. So I got one answer. Answer is D. So I'll wait for another other answers, then I will solve it. Let me do it from scratch. Okay. So these are the points, right? So what we have to do is that at first find the here, as we are considering similarity, so we have to find the highest similarities. So at first ignore our diagonals, because diagonals are single point. We have to find something that we can match. So other than one, what are the highest point here in the data? 0.95, right? P2, P3. So this is highest, right? So at first we will merge P2 and P3. So it will be like this. Suppose here P2, P3, we are merging, okay. P2, P3 is merged. Then again we have to look what are the highest, except what we have already taken. So P2, P3 is done. Other than that, which one is highest here? I got 1.80 here, 0.85, yeah, 0.85 is there. Anything else which is higher than this? I don't think so. Okay, so let's go ahead. P6 and P5. Okay. So P6 and P5 are not related to this. P5 and P6.
Sir, please try to explain again why we are selecting P2 and P3
Okay.
in the first step.
Yeah. So in this matrix, we have to select one with the highest similarity or lowest distance. So P2 and P3 is having the highest similarity. So I mean they are closer, right? They are having lowest distance. So that is why we are selecting those, like one with highest similarity. If you ignore the diagonals, you have 0.95 as the highest value.
So why we are not taking one?
Okay, so one is for like P1, P1. So P1, P1 is already a point, right? We cannot, like, they are kind of already matched. This is like,
Okay, diagonal we have to
yeah,
ignore
they are already a point.
because all are same point.
So then, like, we take the P2, P3, right? 0.95. So P2 and P3 is merged, okay? Then we have to find out what are the like next, what we can merge next. So next is 0.85 is the second highest, right? So we are merging that P5 and P6, and P5 and P6 the threshold will be little bit higher than the previous one, because that was like 0.95, it is 0.85. Okay, so P2 P3 merged and P5 P6 is merged. What can you merge next?
Point 80.
0.80. Here we have 0.80. P4 with P5.
P4 P4.
Right. Okay. So P5 is already merged with P6. Okay. So if you are taking P4 here, we have to merge with that also. So at this point, P5 and P6 is merged. So we are doing this. Okay. After that, after 0.80, what are the next values?
0.75. P3 P4.
Yeah, 0.75 is between P3 P4.
So it may be one case, suppose 0.75 for other two nodes also. It may be happen.
In that case, you can choose either one.
Suppose it may be for P1 P6 also 0.75 and P3 P4 also 0.75. Then what will
You can choose either one of them. Like there can be multiple.
okay either okay any of them I can choose. The answer then it will vary, no?
Yeah. So actually, in case of if you are getting the same threshold, okay, you can do both actually. So suppose let's say we are having some points here, maybe P1, P2, P3, P4, and suppose between P1, P2 it is 0.90 and P2, P3, P4 is also 0.90. So you can merge both of them at the same level, right? So that also you can do.
Okay.
So next we can merge 0.75, right? P3 and P4. P3 and P4. Okay. So P3 is already merged with P2 and P4 is already merged with this. So anyway, a little bit higher than this, we'll merge this. Okay, P2 P3. Then after 0.75, what can you merge?
0.7 P2 P4
P2 P4.
and P1 P2 and P1 P2 also.
Okay, so let's P1 P2 and P1 P2 is already merged, I guess.
No.
P1 P2 is not merged. Okay, so we can do this. P1. So this is the final one. Or like even if you go with 0.7 P4 P2. So P4 P2 you can see P4 and P2 at this point it is already merged, right? So like we have to kind of figure right now P1 and P2. So this is like if you want to build this from scratch, but if you are considering the MCQs, okay, there is a kind of a simpler way. So what you do is that see from the like below what is here P1 P6 is merging and here P2 P3 is merging, P1 P6 and P2 P3. So I am seeing at the lowest level, right? So see here P1 P2 distance is not distance, similarity is 0.70 and P1 P6 yeah. Just wait a minute. P1 P6 P1 P6 is 0.05 and P2 P3 is 0.95. so there are like basically two options here, like because P1 P6 they are same. Similarly P2 P3 P2 P3 they are same, right? So we have basically two options at the first at the lowest node, and we have two options here, 0.05 and 0.95. So what we need to choose? We need to choose 0.95 because we are considering similarity. So either this option or this option will be correct. C and A are not correct. Then P5 P6 next level, so both are okay. After that we got P23 with P4, and here we got P4 with P5 and P6, right? So let's first do this. P23 with P4. So P23 with P4. So let's go to these rows P2 and P3, and P4 here intersection is 0.70 and 0.7, right? So what is the highest similarity here? 0.75. So here the value is 0.75. Here P5 P6 with P4. So P5 P6 with P4. Let's go here. These are the values 0.80. So here the highest is 0.75 and here the highest is 0.80. So we have to choose this. So by this, if you are having options, you can do this quickly via this, like by elimination. So I hope everyone understood that. If you are have any doubts, you can ask.
Sir, while comparing for 0.7, in P4 also 0.7 is there, sir. Do we need to consider that? And also in P2 2.7 is there.
Okay.
So could you
You are saying
clarify that, sir?
P2 P4 and P1 P2, right? Okay.
Yes.
Okay. So so suppose at this point, right? So we are considering we have already done up to this point. Okay, up to this point we have already done. Now we are considering that there are two options, right? One is let's say we are choosing this one, P2 and P4. Okay. So how to merge P2 and P4? We see if we try to merge P2 and P4, they are already merged at this point, right? So it is already merged, so we don't bother about it. Then what are the other options? We go with that. So suppose even if it's, let's say it is 0.73, okay, let's say it is 0.73, then also if you are merging P2 and P4, we can say that P2 and P4 is already merged, so we cannot merge it. So we'll ignore this value and then go to the next value.
Okay, sir. Thank you.
Okay, so this is the last question, and then after that I'll go to the coding. So you have three clusters, and these are the points in the cluster, and you have to find the centroids. So what are the centroids? None of this. Option A. Okay. Any more answers? Okay, so everyone is saying A. So A is actually the correct answer. So to find the centroids, you have to take kind of just average. So 2 plus 4 plus 6 is 12 divided by 3 is 4. Same for this also, 2 plus 4 plus 6 divided by 3 is 4. So only this one is correct. Okay, so we also have none of this. Okay, let's go ahead. 0 plus 4 divided by 2 is 2. 4 plus 0 divided by 2 is 2. So this one. And 5 plus 9 is 14. 14 divided by 2 is 7. Same for this. So this is like very easy to calculate. So first option is the correct one. Okay. So we are done with the questions. Then let's go.
Sir, can you repeat?
Yeah. So to find the centroids, you have to just take coordinate wise average. Okay. So 2 plus 4 plus 6 is 2 plus 4 is 6. 6 plus 6 is 12, and we have 3 points here. So 12 divided by 3 is 3. Sorry, 12 divided by 3 is 4, right? Same for this one. 2 plus 4 plus 6 divided by 3 is 4. So for the first cluster, the centroid is 4, 4, 4. Okay. For the second cluster, 0, 4, 4, 0. So 0 plus 4 divided by 2 is 2, and 4 plus 0 divided by 2 is 2. So because there are like 2 points here. So here the centroid is 2, 2. Same here also, there are 1 point and 1 point. So 2 points are there. 5 plus 9 equal to 14. 14 divided by 2 is 7. So 7, 7.
Okay, sir.
So let me move on to the coding session. Okay, so even though I will discuss about the even though I will discuss about what I have given in the assignment, but I'll not perform the exact thing. So I will use the IRIS dataset, but I will show how to do KNN and PCA, but I'll not give you the solution for the assignments. You have to find that one. Okay. So at first we have just imported some stuff here. So NumPy is a library for matrix operations. Pandas is for dealing with datasets. Matplotlib is for generating graphs. sklearn, in sklearn we are using the dataset for importing the data, IRIS data, and Seaborn again we are using for plotting for graphs, and we are using some clustering algorithms. Okay, so this is the Colab notebook, and I am running this. So at first, after importing, we will import the data with load IRIS. Okay, so it is connected. Let's go on. Okay, so then it will automatically download the data and store it to this variable, IRIS variable, and let's find out what is there in the variable. Okay. So this is basically the variable. So we have a data column, and in the data we have 4 columns and 150 rows. Okay, so these are the for every row there are 4 values, and what are the values we'll find out. Okay. So these are the data. Okay, and these are the labels. Labels mean in the clustering generally what happens is that we don't have any labels because it is unsupervised, but in this case we have the labels. So that is an advantage here. Okay, so what are the target names? Target names means what are the labels. So here 0 means Setosa, 1 means versicolor, and 2 means virginica. Okay, and then we have the dataset description. So we can see here feature names. Feature names means we have 4 columns, right? Here we have 4 values for every row. So what are the features? First one is sepal length, sepal width, petal length, petal width. So basically iris dataset is actually a flower dataset, and we have the specification of the data, like what are the length of the sepal, what is the length of the petal, things like that, and we have to classify them into 3 categories, like 3 clusters. Okay. So now we have some dataset description anyway. So let's do one thing. We have the data. So iris.data is the if you see here, we have the data within the iris value. We have the dictionary. Iris is a dictionary, and within that we have a like with data key we have the array. So basically we are taking this, we are converting this to data frame. So this is the just the data, and columns we are supplying the column names, and the column names are feature names, iris feature names, which are basically sepal length, petal width, petal length, and petal width. Okay, so these are the like names of the table that we are creating. And then so after creating the table, after getting the data frame, we are printing the head. Head means like it will show the first 5 rows of the data. Okay, so this is the data. So this is the serial number index, basically sepal length, sepal width, petal length, petal width. Okay, so these are the values that we are having there. Okay, so we can do also one thing. We can write data describe, so it will give some statistics about the data. So yeah, so count means how many values are there, 150, and what is the mean value, 5.84, 3.05, like that. What is the standard deviation, and what is the minimum value, what is the maximum value, and what are the percentiles. So you can if you want to know more about the data, you can use describe to get those. Okay, then what we are doing is that we are just converting this to an numpy array. Okay, so basically here we have the data, and we are just we are removing the dictionary format. We are removing this like sepal length, petal length, this kind of thing, and we are just converting to the just the values. Okay, then we are taking an CSS. This is a list. Okay, this is a list, and then for multiple values we are trying 8 values, and for that we are using K-means clustering algorithm. Okay, so what is there in K-means function? Okay, so if you look into this, let me go to the documentation. So these are the things you need to provide in cluster. What are the number of clusters you want, what are the initializations, so there are different algorithms initialized, and then other stuff. Okay, so how many iterations you want to run, these kind of things. So you can check this out. So what we are doing is that for multiple values, so in the lectures NIM method is covered. So what we do is that we try multiple k values, and we plot a graph, and then we find out what is the optimal number of clusters. So NIM method is also known as ELBO method. Okay, so like they are used interchangeably. Okay, so at first what we are doing is that for the first iteration, in clusters is I. Okay, so at the first iteration it will be like 1, then second iteration it will be like 2, and for every iteration, for every time we are run, for every value of k, we are running max iteration equal to 100, and that's it actually. So just random state we are using for reproducibility. Okay, and then after that we are fitting it on the x. So x is the data set we have obtained here, right? So then we are appending the CSS value. So basically what is happening here is that for every value of k, we are performing the k-means clustering algorithm here, and then we are calculating the inertia of that with that value of k. Then we are saving this to the list. Okay. So after we are done with this, what we are doing is that we are plotting. Plotting it means like we are just drawing a graph to present the values. Okay. So this is the plot. Okay, and also let me print the CSS file. So this is the CSS values. So first for k equal to 1, this is the value, k equal to 2, this is the value, k equal to 3, this is the value. So from this we can see that CSS value is very high for k equal to 1. It has dropped significantly for k equal to 2. For k equal to 3, it has been it has dropped again, but for k equal to 4, it is not dropping that much. Okay, so maybe we can consider 3 is the optimal value for clustering here. Okay, because after 3, it is kind of getting as a straight line, like this perpendicular line, parallel line with respect to the x-axis. So okay, so this is with by this we found out that if we are using k equal to 3, then we'll get a good cluster. So after that, let me initialize again with k equal to 3 in cluster equal to 3, and then let me plot that graph if we are using k equal to 3. Okay, so this is the graph here. So blue, we are so blue is one flower, red is one flower, and green is another flower originally. And this is the here we have one cluster centered here, another cluster centered here, and another cluster centered here. Okay. So these are the centers that we are having. So this is with k-means algorithm. Then let's go to partial algorithm. So I hope it is clear to everyone how to plot this kind of things. Okay. So in the question, the values are different. How to calculate number of clusters and thresholds are different. I am using different threshold anyway. So how to use this one? But you can import via this. So from sklearn.cluster import batch. Okay. So if you use this, you can use this class to perform calculation. So here in cluster equal to 3 and threshold equal to 1, which is like arbitrary value that I am using, and what will happen is that after initializing that with these parameters, then we are asking to fit that fit on the data x. So x is the data, here you can see x is the data we have obtained here, right? Let me see. X is the data, just the data without any dictionary or without any column names or anything, just the raw data. So we are just using the raw data here, and we are just using the raw data here, and we are asking to kind of fit it on the data and also give the labels after fitting. Okay, so this is the labels after fitting. So again, let me plot the graph. Okay, So this is the graph here, okay, with this is the graph with the batch algorithm, and then let me print the labels. Okay, so 1, 2, 0, these are the labels, right? So initially, what are the labels? So initially this was like up to some point only 0 was there, only one label was there, another up to another point only another label, and up to some other point another level. But here you can see within 2 there is 0, within 0 there are 2, they are a kind of like interchange. So it is like there are some errors in the prediction, right? So how to calculate the RAND score? So let me go to the sklearn RAND score documentation. Yes. So you have to provide this, okay, you have to import this, and then you have to provide the true levels and predicted levels. So true levels, we have the true levels given in the dataset, right? And predicted levels we have in the like k-means in the Birch algorithm. So let's find out. So basically, Iris is the name of the data, right? Like Iris is the variable for the data here. Okay. So this is the iris, okay, and within that iris is basically a dictionary, and within that we have this target, right? So the target is labels here, okay. So at first in the first argument we need the labels true, like what is the original labels. So what we have to do, iris is the value here, iris is the dictionary here, and within that dictionary we are choosing the target. So target is the name of the key here, okay, where we have all the labels, and y Birch is the prediction we have obtained from here, okay. So then how to find out that random index? Just run this and sklearn will automatically find the algorithm is already implemented in here. Okay. So if we print the rand index, this will 0.8660. So just for example, if we want to see number of cluster equal to 2 and number of threshold equal to 1, that we can also do. Just change the values and run it. Okay. So with number of cluster equal to 2, the rand index is 0.77, and with number of cluster equal to 3, the rand index is 0.86. Let me see with 4 also. Okay, I think with 4, okay. So this cell is only for plotting, and this is one just for this is the cell for like predicting. Just 2 lines of code. Yeah, even with like equal to 4, it is coming out to be 0.86. Okay. So this is the for Birch algorithm. Then how to do PCA? So again, let me refer to the PCA documentation here. So sklearn.decomposition.pca. So at first you have to import that from sklearn.decomposition import pca. So is it done somewhere or okay, so it is not imported here. Yeah, so from sklearn.decomposition import pca, so that is done. Then we have to initialize the pca. So pca, you can see you can call the pca, and we have to provide the number of components here, and then these are just some extra parameters. We don't really need to worry about those. Random state, let me give a random state here, so that it is reproducible. Okay, so after initialization, we'll fit that pca.fit given x. So x is the data as we have discussed. So after fitting, we'll obtain after the pca has been fitted with x. Okay, then we'll apply the transform method. So pca, so let me go here. So yeah, you can see the examples here also. So pca n components equal to 2, and then pca dot fit, it will fit the data. It will fit the data, and then if you apply the transform, if you call the transform, then it will transform the data and provide you the resultant values. Okay, so initially what are the dimensions here? So dimension for yeah, so initially it was 150,3. Okay, and after maybe in components, let me do it to 2. Okay, in components equal to 2. Let's say in component 2. And it has transformed, and then see, you are seeing the only one column because we are selecting in component equal to 2. And then if you want to see the shape here also, it should be 150,1. Yes. Okay, so here, because we are using 0, 3, so 0, 1, only 3 columns are taken. So let me do all columns. Okay, even with all the columns, so we can see 3 is the value. Okay, and yeah, with all the 4 columns, if you are using, these are the css values, then So let me perform this again. Okay, we have already obtained the y batch. So if we want to calculate the rand score, okay, everything else is same. We are just using 4 columns instead of 3. That's it. So this is the value 885. And then suppose with PCA there are 4 components initially, and suppose we are reducing it to 3 components, so we can do like this. Okay, so now we can see XSF is 150,4 because there are 4 columns. We have taken all the columns. And now it should be 150,3. So you have reduced 150,4 to 150,3 with PC. Okay, so suppose we are having this value now, x underscore. This is the value after let's say after performing the PCA. Okay, so then if we want to perform DB scan, how can you do this? So again, if you go to the documentation of DB scan, so this is true for any other algorithms also in sklearn. You need just to search for alternative. Also there are libraries, so you can just use them directly. So again, sklearn.cluster.dbscan. So this should be imported from sklearn.cluster import dbscan. This is done. Then we have to initialize that. So initialize EPS equal to 0.5 is, if we don't give any EPS, it will be 0.5 by default, but we are providing EPS equal to 0.3. Then mean samples we are setting it to 3, and we are providing the x underscore, so which is the transform data, right? Transformed by PC. So if we do this, then these are the labels. Okay, these are the labels that we are getting. Okay, and you can observe that there are some minus ones here. So minus ones are the one that are let's say outliers. So if you want to find the number of outliers, you can find out using that. If you count the number of minus one, then that is the number of outliers. And if we do not use the transform data, if you just use the data directly, what will be the levels? This will be the levels. You can see there are much more noise here if we are using the original data. Okay. So I hope it is clear to everyone. If you are have any doubts, or if you want to implement any other algorithm from clustering, you can let me know. I'll try to help. So maybe let me show the alternative also. So first you need to copy this. the parameters that we need to provide. Number of clusters to and anything else. So maybe I just provide any clusters for that. Okay, then what do we need to do? We need to fit x and we can see the level. So if you fit the original data, which is x, so this is shift x. So let me try that one. Okay. So this is the levels with the cluster. And also, like if you want to preserve a histogram, that is also possible. So let me find out some visualization for you. You need to use this module. Then just use the yes. So basically there are in the like let me do it with the after PCA. If we want to do it after the PCA, so there are like 3 dimensions. Okay, and these are the levels. And suppose yeah, these are the levels. And suppose you want to plot. So if we want to plot only 2 dimensions, so we can do this. Okay, so x is the like value here that we are obtained here, like x underscore after PCA. So then we have to do we have to always check the values of those. So let me just print x just once. So this is the array. Then we are taking all the rows and maybe just first column Sorry, so actually earlier I used 0 in both the cases, so obviously it is not going to work. So yeah, after transforming to PCA, these are the three clusters. Okay. So if you do it, this is like with 0 1, okay, with the 0 dimension and second first dimension, and then it can be like all three combinations, okay, and also like we can transform it to 2 dimension also, and then I think, yeah, let me do it 2 dimension, and visualization will be much more clear because we are visualizing on 2D. Yeah, so it has run completely. Okay, so this is the clusters, and let me draw the dendrogram also. Okay, so we are considering only two principal components, so the indexes are 0 and 1, so we have to stick to that. So this should be, so you can see the dendrogram here. Obviously, like there are many points, so it is difficult to see, but basically there will be 150 points, right, because there are 150 rows in the data, so 150 points they are getting merged at some point, they are getting merged at some point, and they are forming clusters here, then getting merged again at some point. At this point maybe we have 1 2 3 4 5 6. At this point we have 6 clusters, then again after some threshold we are merging again after that, like this, okay. So you can visualize it in this way, okay. So if you want to learn about any other clustering algorithm implementation, you can ask. If you have any question, you can ask.
Sir, how can we solve the assignment question 8 and 9 by programming?
Yeah, assignment 8 and 9, they are coding questions, right? So whatever I have shown, this is like very similar to those questions, right? Dataset is also same. I have used Irish dataset only, but obviously not the exact values. So just use those libraries that I have used here. Okay, so one is with Birch, so use that Birch here. Use this one only. Okay, whatever specification it is given in the question, use that and calculate those rand index value that you can do. And also this one, I think another one is about PCA and DBScan, that also you can use those.
PC and DB scan.
So like just use the standard library of the Scala.
So we can only changing the component and random state and these values. If we run the program, the answer will be, you can get the answer.
You should.
Yeah. Will you share this programming?
Yeah, so actually it is in the in the like in the folder. I'll move it into this folder where we are sharing the PowerPoints. So if you go here, if you go here, problem solving session, go here and
Google Drive, in the Google Drive.
in here. Okay, open the link and I will update in this one.
Okay. Okay. So one more question. You have shown with the uh, similarity one problem is there
Yeah.
with the table, single link clustering. So can you, with the same table, can you show the complex link clustering algorithm for distant matrix
Yeah, sure.
with the same, how to?
Okay, so okay, before that, let me do one thing. So yeah, complete link is a little bit difficult because complete link, yeah, revised link is difficult because you
complex
yeah.
complex link clustering algorithm for distance matrix.
So you are saying complete link, right?
Complete link, sir.
Okay.
Complete link clustering algorithm
Yeah,
for distance matrix.
I'll show. Before that, let me just share it the Colab file here also.
One more link you have shared. What is that one, sir?
Yeah, this is the Colab
Previously.
link actually. The,
No, not this one. Previous one.
no,
Previous two.
that was for like the drawing that I was doing.
Okay. So when I try to open it, it says
Yeah.
access denied.
So this is the data point, right? So
Yes, with this data.
So with complete link, what we need to find is that the one with highest distance, right?
Yes,
Highest
with
distance,
distance matrix.
yes, highest distance means least similarity. So least similarity, where can you get? 0.05. Least similarity means highest distance. So 0.05, I think nothing else is less than 0.5. So P1 and P6 will match first.
So
Sir,
in the presentation views,
You can't see the presentation?
presentation,
Sorry, you are unclear.
so make it presentation view, sir.
So you are not able to see the, yeah, so this is the,
Uh, yes, full screen.
yeah. But for drawing I need to use that also, so that is why I asked. So in these,
Okay, sir.
go for the one with highest distance. Highest distance means lowest similarity. So here the lowest similarity is 0.05. So P1 and P6 we have to match first. Then after that, what can we merge after 0.5? We have 0.20, anything lower than that? I don't think anything lower than that is there. So let's merge 0.1 and 0.5. 0.5, let's say take it here. 0.1 is already merged with this, so we'll merge on top of that. 0.1, 0.5 is done. Let's check the next values. After 0.20 we have 0.40. Do we have anything else? So 0.40 with P1, P4 and P3, P6. Okay. So P1, P4, let's consider this. And P3, P6. They are the similar, so let me do one thing, just little bit above. Or you can do other way also. Okay, so this one first, then this one. This is like basically because they are same, but we can merge only two at a time. So we are doing this. Okay.
So last two step, how you do this?
Okay.
P1 and P4.
So let me go here. So there are two values, P1, P4 with 0.40 and P3, P6 with 0.40, right? So we can do either way. So P1, P4, if we want to merge, we can merge, and P3, P6, we can also merge. So okay, so basically both are sharing both are
Same values.
yes, both are having same values. So basically here, as we can only merge two values, so we can choose this one first and this one second, this one first or this one second. Okay. If they are merging together. If they are independent, like maybe say P3, P5 and P1, P6, then we can merge at same level. Here we can just give a little bit distance and we can merge. like this one after this one or this one after this one doesn't matter. You can
Okay,
use
okay.
either. And then
So after connecting the all the 6 point, then it is complete, no?
yes.
Okay.
So we have already connected 5 point and we already have P2 left, I think. So anyway, so if we only have 1 point left, it will be connected that way. So P2 will be with everything else.
Because others are in the same level
Yeah.
now.
Yes. Yeah, so let me just check 1 second. P1 at first P1 P6, which is done. Then
Where value is 0.05.
yeah, then P1 P5.
P1.
P1 is merged with P6. Okay, P5. Fine.
What is the value, sir?
0.20.
Point
Then 0.40. Okay.
two are there.
Yeah.
Four P4
P1
P6
P4 and
P3 P3 P6.
P3 P6. Yeah. So P1 P4 and P3 P6. So like both of them are connected to this level. Okay. So that is why like we are just using one after another. Doesn't matter what you use. And then only remaining is P2. Yeah.
So how it is like a complex link clustering? What is the difference between complex link and single link approach?
So are you meaning to say that average link?
In the question, it is complex link clustering. It's
In
in the assignment question.
okay, so that I cannot say.
It's the question. Then you know, they asked to solve with the single link clustering also and complex link clustering also.
Yeah, so actually I cannot really comment on that. You can just
No, no, you just tell me the what is the difference so that we can solve. No? We are not asking the same problem you have to solve.
I have no idea actually about complex clustering. So maybe this
Also,
is
this is single link approach.
which one?
What we have solved now just now.
Uh, yeah, this one just now it is completely not complex. Yeah. So what happens is single link is that you are considering the minimum distance. In complete link you are considering the maximum distance.
Can you repeat?
So in the single link you will merge the clusters with the lowest distance. Okay. And
Yes.
in the complete link you will merge the clusters with highest distance.
So just now what we do that is complex link only, no?
Yeah, complete link.
Okay. That is opposite one.
Yeah,
Previously with the highest similarity and next one what we have done now that
lowest
is
similarity.
lowest similarity.
Right.
That is the complex link cluster. Thank you.
Okay, so maybe we can end the session right now.
So what about the cures or CURE? I didn't find anything in the video lecture cure algorithm.
No, QQ algorithm is they are covered uh, in
Okay,
yeah,
maybe I missed.
yeah, the QR algorithm part. Can you see?
Okay, okay.
So thank you everyone for joining. Have a nice day.